automatically, because see how many devices are connected then. You just imagine that. So we need IP for that particular purpose, and we will see some of the reasons, what are the main key advantages of the IP for the Internet of Things. First advantage is that open and standards based. So definitely IP lets you to create a new paradigm in which devices, applications and users can have a large set of devices, and you can have any number of functionalities. You can think about it. See, there is no end for human thinking in implementing any services for Internet of Things. It can be applied for anything. Just keep on imagining. You can take agriculture field, just imagine beyond, you'll get a many number of services. You can go to the hospital, think beyond. Think beyond always. Go to the education sector, think beyond. You'll get a plenty of any number of functionalities, devices, interchangeability, interoperability, security, and management. So we have to then go for IP based, which is open and standard based, and we need for validation and deployment purpose and other things. And there are some consortiums that they provide some open standards. They focuses on the development of the IP suite and related internet technologies and protocols. So you can still make improvements in the technologies and all. Second advantage of this IP for Internet of Things is versatile. So we know already that versatile, like it can be connected for any number of devices. Additional protocols and technologies can also be used. So anywhere it can be applied. So I can say like functionalities can be implemented more. It can be used in layered IP architecture, is well equipped to cope up with any type of, see, look at here, any type of physical and data link layers. That's the reason this IP is a versatile for IoT. Third reason is that ubiquitous. That means it can be applied on and anywhere, present in all the kind of things, not from only the specific applications. From tiny OS, look at here the word from tiny OS.
Hey Salva, mic testing 1 2 3. 1 2 3.
Just mute your audio. Class is going on. It's not any. I'm not able to see who is you, but I'm just going through the slides. Mute your audio wherever you are, and just mute your audio. Ubiquitous means it can be present in any of the applications. See, we have another 10 minutes of time. Already 30 minutes is completed. Let me take another 10 minutes of time, and we'll see how many slides we can cover up. From tiny OS. Tiny OS means it can be embedded into a small devices, which can work just like your operating system, which can take up all the services as the normal OS can do it out. So it can be present in any of the operating systems, from lightweight to the embedded systems to the any general purpose systems also. It can be integrated in dual mode also. You can apply. That means the device can have both V4 and V6 versions of IPs also. Next, fourth advantage of this IP is scalable. As we know already, scalable means it can be increasable. That means you can apply this IP for any number of devices, and any large number of devices can be connected. Millions of private and public IP infrastructure nodes can also be connected. It can offer strong foundations, anything like so you can add huge numbers of things to private and public infrastructures. So that is the power of IP. That's scalable. Fifth one is manageable and highly secure. Since IP itself has a security for your data, which you can transmit between the various nodes. So it has security capabilities, and network management and security protocols, mechanisms, and tool sets all are available in the IP business application to OT, so which we used already, that OT protocols. So I can say that from this slide, it is easily manageable and highly secureable. Sixth advantage of this IP is that stable and resilient. So IP is workable solution. That means you can add up, you can change, you can make some modifications. It's a well-established knowledge base, and more importantly, it has been used for years critical infrastructure such as financial and defense networks. So you can have, and this IP has been deployed for critical services such as voice and video. I think video surveillance, voice surveillance, which wherever you can use it. Okay, and finally, for stability and resilience, even a bit from the large ecosystem of IT professionals who can help design, deploy, and operate IP-based solutions. I mean, I think nowadays almost all we have IP-based solution for every problem. You have IP-based solution only. So where the stability, resiliency is there with the IP Internet Protocol. Sixth reason. Seventh is consumers market adoption. That means consumers are called the vendors. Easily accessibility to the various applications and devices. So it can be through broadband or through mobile wireless infrastructures. Or you can even, these consumer devices can range from smartphones to tablets and PCs. Right now, the Zoom, we can connect through mobile and we can connect to laptop or a tablet or anything else. You can connect to that particular things also. That means IP lets us to communicate with various networks infrastructures. Eighth, and the last reason, last advantage of this IP is innovation factor. That means there are so many innovations already done because this underlying protocol application ranging from file transfer, email to the wild web, e-commerce, social networking, mobility, and many more. You can use IP for many purposes, not only for transferring the file, not only for email purpose, e-commerce, social networking, mobility. For many other purposes, this IP is mainly used. Okay. Um, yeah, these are the 8 reasons, I mean, key advantages of IP. I mean, they can ask you definitely for 8 marks. Explain that. Okay, I'll go to the next slide quickly. Somewhere we can stop it because hardly we have another 5 minutes to 5 minutes in your hands to end this session. Take the next heading is adoption or adoption. So look at the word. We have two things, adopt and adapt. So adoption means application layered gateways that we call as ALGs must be implemented to ensure the translation between non-IP and IP layers. That means we need to translate between non-internet protocol and internet protocol layers. Then we use adopt. Adopt means we will be replacing all the non-IP layers with their IP layer counterparts, simplifying the deployment model and operations. I mean, we don't want to use non-IP. Replace all non-IP by internet protocol layers, IP layers, because which lets us to simplify, because the model is easily deployable on any of the devices or any of the applications. That's the main reason we have to go for adopt, not adapt. So we'll see the some other points about this adopt and adopt. So I think we use already word SCADA, okay, supervisory control and data acquisition applications. So these are some typical examples of vertical market deployments that operate both IP adaptation model and adoption model. So in the SCADA, what happens is that the automation control system for remote monitoring and control of the equipment. Do we require this adoptions? Okay. So implementation of that makes use of adoption have a SCADA devices attached through serial interfaces to gateway tunneling or translating the traffic. Here we use adoption. Okay. And while we want to adopt, the SCADA devices are attached via Ethernet to switches. So if you want, I mean, serial interfaces for this particular, we use adapt. For the same IP, if you want to apply for SCADA, then it should be adopted. Okay, adoption model can be used via Ethernet into switches. I mean, I think definitely we use IP, which communicates with various other devices. Example, you can see one such example is Zigbee solution that runs non-IP stack between devices and a Zigbee gateway that forwards traffic to an application layer. A Zigbee gateway often acts as a translator between the Zigbee and IP protocol stacks. And see some differences where we use Zigbee for non-IP stack, which is mainly meant for forwarding the traffic between the various servers. We'll quickly go through this heading, and probably we need to stop here with this heading. So what is that? We need to consider some factors when we are trying to determine which model is suited, best suited for last mile connectivity. That means, do you really require adoption or adoption? Which is suitable? We have to consider some points or some factors. before you determine which is suitable for me, for my applications. Suited for last mile connected. Last mile means very far away distance where you can have the sensors are connected. So first factor you need to keep it in mind is that bidirectional versus unidirectional data flow. Which is suitable for you? Do you require bidirectional? Do you require unidirectional data flow? So you have to again decide here. So normally we expect bidirectional for some last mile technologies offer optimization for unidirectional communications. So you can have this some the ranges. Look at here some of the class of IoT devices which have some name. They infrequently need to report a few bytes of data to an application because they need to keep on. I think, do you know or not, your nearby mobile tower networks, they need to report, they need to inform to your mobile, or your mobile needs to report to your nearest tower that you are in a coverage range or area, because there is a flag bit is kept in the nearby tower which is keep on always monitoring you. Is it a bidirectional or unidirectional? So that you need to think about it. Which communications I require for my application, that should be decided by you. One way communication is best or two way communication is better. If I use one way, definitely one way communication is faster, definitely. But which application you require, that you decide. Okay. Then second factor is that overhead for last mile communication paths. Overhead means delay or some disturbances, some issues. So which leads to overhead. Suppose if you are using IPv4 and it requires 20 bytes of header at a minimum. But if you use IPv6, you require 40 bytes at the IP network layer. So when you're transmitting the data, UDP of this category has 8 bytes of header overload, while TCP has a minimum of 20 bytes. And again, just look at here. So which requires overhead means as the payload or the things gets more, definitely there is a delay might be occurred. So when your consideration of applies to control plane traffic, look at here, that is on or IP for low bandwidth last mile links. So which is suitable? Again, this is another factor to be decided. And the last point, I'll end up this session with this data flow model. So which kind of technology, adaptation or adoption, which is allowing us to easily exchange the data? Look at here, which allows us to exchange the data easily from node to node, end-to-end concept. And the devices that data flow is limited, a translation of traffic needs end device and one or two application servers. So depending upon the network topology and the data flow, you have to again decide. So yes, another network diversity. Yes, this is the last point of last factor, network diversity.